Hello, everyone. You're welcome once again to another wonderful section of Science and Mathematics with your one and only Anderson Ikechukwu Nathaniel. In today's section of Science and Mathematics, we're going to continue with our circle geometry series in mathematics. And on today's episode, we're going to look at the theorem 2 in our circle geometry. But before I continue, I know most of you out there mixed our last section on the first episode of the circle geometry series. If you among such persons who missed the last section, I implore you to check the description box, click the link below so that you would be able to watch the last section of our first episode of circle geometry. Now, in today's episode of circle geometry, we're looking at theorem 2. This particular theorem 2, it's something I call the isosceles triangular theorem. It's not really in your textbooks or that, but I had to coin that out because it confuses most persons when they're actually solving questions. So I call it isosceles triangle theorem. Now, before we'll continue on this theorem, please, if you're yet to subscribe to my YouTube channel, I'll plead with you to hit the subscription button below so that you can always get notified whenever I post a new video. And please don't forget to do what? To share and like my videos out there. Now let's delve into the isosceles triangle theorem. Now, what do we know about the isosceles triangle theorem? When we say isosceles triangle theorem, it is something like this. I'll draw a circle. Now, in this circle, we have our midpoint here. We have a horizontal line being drawn from one circumference end to another circumference end. So this is called circumference. The outer layer of your circle is called a circumference. Now when you have a horizontal line drawn from one end of a circle to another end of a circle, this is called a chord. It is called a chord. Now, an isosceles triangle is formed when two radius are drawn from the center of the circle to meet the both ends of a chord. When two radius are drawn from where? From the center of a circle to meet both ends of a chord, or when two lines, these lines are called radius. So this is a radii, this is a radii. Now it means that the two sides are equal. Now what is an isosceles triangle? We do know that an isosceles triangle refers to what? Two equal sides with two equal what? Angles. So we have two equal sides and two equal angles. So if this is O and this is A and this is B, it simply implies that triangle OAB is simply equal to triangle what? OBA. Triangle OAB is simply equal to triangle OBA. Why? We call that base angles of an isosceles triangle. Base angles of an isosceles triangle. Good. So that's our reason for doing that. We're going to take an example that's going to contain the first theorem that I made and the second theorem. Okay, we have a circle. We have a triangle inside the circle. Then from the center of the circle, we also have a triangle. This is A, B, C, and this is O. This is 40 degrees. Now please, in the last section of my circle geometry, I did emphasize that what? Any triangle that meets the circumference of a circle is known as the circumference angle. So you can see the triangle is touching the circle here. Because it's touching this circle, it means 40 is what? It's my angle at the circumference of what? Triangle ABC. Now, this is the question. So my question says, if triangle BAC is equal to 40 degrees, find I triangle OBC to triangle OCB. For us to solve this question, there is really something we need to do here. What do we need to do? In the last section, I did say that what? The angle at the center is twice the angle at what? The circumference. Before we can get OBC or triangle OCB, we need to get the what? The angle at the center here. We need to get this angle here. Solution. So this is our solution. Triangle BOC is simply equal to 2 times 40 degrees. Why? Angle at the center is twice. Okay, let me draw this one. The angle at the circumference. Angle at the center is twice the angle at the circumference. Therefore, that means that what? Triangle BOC is equal to 80 degrees. That means here is 80 degrees. Do you understand? Now, since here is 80 degrees, it is easy for me to get the angle here. Let me call the angle here X, and let me call the angle here Y. Now, X here represents triangle OBC, and Y here represents triangle OCB. Now, why do I put my X here? I did say in my last section that whenever you're given 3 alphabets, the alphabet at the middle is the owner of that angle. So the angle is not at O, neither is the angle at B. Here, the angle is not at O, neither is the angle at C. The angle for question 1 is where? Is in B. And the angle for question 2 is in C. That is why you see me put X here and you see me put what? Y there. Okay, we can clean this side. Now, one thing you need to take note of is that Angle in a triangle is equal to 180 degree. Angle in a triangle is equal to what? 180 degree. It's important you know that sum of angles in a triangle is called what? It's called interior. It's called an interior angle. So angle within a triangle, or interior angles, or sum of interior angles in a triangle, is equals to 180 degree. So I can say 80 degree plus x plus y is equals to 180 degree. But I can't do anything here because I'm having two alphabets. But then remember the theorem. The theorem says that what? A line drawn from the center of your circle to touch both ends, or to meet both ends of your chord, forms a what? An isosceles triangle. It forms an isosceles triangle. Therefore, I can say that x is equal, or I can say that y is equal to x based on what? Equal base of an isosceles triangle. Equal base of an isosceles triangle. Since y is equals to x, it simply means that wherever I see y, I will put x. Therefore, I have 80 degree plus x is equals to 180 degree. Now, if I add x together, I will get what? 2x is equals to 180 degree. From here, I'll make 2x the subject of formula. It becomes 2x is equals to 180 degree minus 80 degree. Why is it minus 80 degree? Because the sign here is positive. Whenever you don't see a sign, it means the sign is what? Positive. So when you do this, you're going to get 2x is equals to 100 degree. Divide both sides by 2. It means that therefore our x is equals to what? 50 degree. So since our x here is equal to 50 degree, we can proceed to getting our triangle OBC. We can proceed to getting our triangle OBC. So let's put it off this side. Now, remember, x is representing triangle OBC. So I'll say, since OBC equal x, it therefore means that what? Triangle OBC is equals to what? 50 degree. Now remember that we said that what? Remember that we said that y is also equal to x, or x is also equal to y. So since x is equals to y, this implies that y is also equals to x, which is equals to what? 50 degree. Why? The reason for that is because both angles are what? Equal bases of what? An isosceles triangle. Therefore, we can say that, so this is our number 1. Therefore, we can say that II, which is number 2, is equals to, that's II number 2, that's triangle OCB, is also equals to what? 50 degree. Now, I did make mention of something earlier. I said I didn't complete my statement when I said that this 80 is a positive sign. Now, the reason for this negative sign is that when a positive figure crosses an equal sign, it becomes negative. The same thing, when a negative figure crosses an equal sign, it becomes what? Positive. So remember that when a positive figure crosses an equal sign, it becomes negative. And when a negative sign crosses an equal sign, it becomes positive. Therefore, we have our answers there. That means now, number 1, triangle OBC is equal to 50 degree, and triangle OCB is also equal to what? 50 degree. Till I come your way on another section of science and mathematics, I remain your host and tutor, Anderson Ikechukwu Nathaniel. Bye for now.